Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, determine the critical points for each function, determine whether the critical point is a local maximum or minimum, and whether or not the tangent is parallel to the horizontal axis. So we are given the function g at t equals t exponent 5 plus t cube. So let's start with the first part where we have to determine the critical points. Now critical points are points at which the derivative of the function is equal to 0 or undefined. So the first step here is to find the derivative of this function. So our first step is, so prime of g at t equals, so the derivative of t exponent 5 can be found using the power rule. So as per the power rule, so the exponent 5 is moved to the front and we should subtract 1 from it. And then plus, we should use power rule for the next term. T exponent 3, we should move the exponent 3 to the front and subtract 1 from 3. Now we can simplify this expression. So we get 5 t exponent 4 plus 3 t exponent 2. Now there is no value of t that will make prime of g at t equal to undefined, because prime of g at t is a polynomial function, so it is not possible for this expression to become undefined. But there are t values that will make this prime of g at t equal to 0. So to find those t values, we'll sub in the left side as 0 and then solve for t. Now we have to solve this equation. So the first step is to factor the right side, so we can do common factoring. So we can factor out t squared. So now we can solve this equation. So we get two cases. So the first case is t squared equals 0. Now we can apply square root to both sides. So square root and square cancel each other out. So we get t equals 0. So that's the first critical number. Now we can analyze the other case. So 5t squared plus 3 equals 0. And now we can isolate t. So first we should subtract 3 from both sides. So the 3's on the left side will cancel out. So 5t squared equals -3. Now we can divide both sides by 5. So the 5's on the left side will get cancelled out. So we get t squared equals -3 over 5. Now it is not possible for a square of a number, positive or negative, to be equal to a negative number. So that means there is no real solution from this case. So we can write no solution. That means there is only one critical number, which is t equals 0. Now in order to find the critical point, we need to find the function value at t equals 0. So we should sub in t as 0 in the given function g at t. So we get g at 0 equals 0 exponent 5 plus 0 exponent 3. So both terms are equal to 0. So g at 0 is equal to 0. So the critical point is 0, comma 0. So there is only one critical point for this function. Now we have to determine where this critical point is a local maximum or local minimum, and for that we can use the first derivative test. So we can use the number line method. So we can draw a number line, we can show the critical number on it, 0. So this critical number divides the number line into two parts. So we have to check for the sign of the derivative of g at t on both sides of this critical number to find whether the function is increasing or decreasing on both sides. So we'll have to use a test value. So on the left side of 0 we can use the test value -1, and on the right side we can use the test value 1. So we'll sub in the first test value -1 in the prime of g at t equation. So prime of g at -1 equals, so we'll sub in t as -1. Now we have to simplify this equation. So -1 exponent 4 is 1, and then -1 exponent 2 is 1. So now we can evaluate it. So we'll get a positive result. So 5 times 1 is 5. So 5 plus 3, which is 8. So that means the function is increasing on the left side of t equals 0. So we got a positive result for prime of g. Now we can find the sign of prime of g to the right side of 0. So we sub in the second test value t as 1. So we sub in t as 1 in the prime of g at t equation, and now we can evaluate it. So 1 exponent 4 is 1, so 5 times 1 is 5. And 1 exponent 2, 1 square is 1, and 3 times 1 will be 3. So we again got a positive result. So prime of g on the right side of the critical number 0 is positive. So we know that if the prime of the function is greater than 0, that means the function is increasing on that interval, and if the prime of g is less than 0, that means the function is decreasing on that interval. Now we can find from this analysis where the critical point is a local maximum or local minimum. Now in this case, the function is increasing on both sides of the critical number. That means the critical point is neither minimum nor maximum point. So we can write our conclusion. So critical point neither local minimum nor local maximum, because function is, or g at t is increasing on both sides of critical point. So this is how you can write your explanation for your answer. So now we are done with the second part. So in the third part, we have to find where the tangent is parallel to the horizontal axis. Now at the critical point, so the x critical point is 0, comma 0. So the t value is 0. And we know that prime of g at t equals 0 is 0 because we found this t equals 0 by subbing in prime of g at t as 0. So prime of g at 0 is equal to 0. So that means the slope of the tangent to this function g at t is equal to 0 because the prime of the function represents the slope of the tangent. So I can explain it here. The slope of tangent equals 0. And we know if the slope of the tangent is 0, that means the tangent is horizontal or parallel to the horizontal axis. Therefore, tangent is parallel to the horizontal axis. So this is a very important concept you need to understand and memorize. So in this case, the critical point is neither minimum nor maximum, but we know that the prime of g at t equals 0, or the critical point, is equal to 0. So that means the slope of the tangent is equal to 0. So that is why the tangent is parallel to the horizontal axis. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.